Good evening, ladies and gentlemen. Today I will compare different preparation for hydrogen production for macroalgas uva fasciata. One is hydrolysis by ultrasonic and surfactant sonic hydrolysis, which proposed Professor Rajesh Banu from Tamil Nadu University in India, in work published in newest issue of High International Journal of Hydrogen Energy, surfactant-mediated sonic hydrolysis of marine macroalgas Ulvas fasciata for biohydrogen production, and I compare the work with similar work with which use hydrolysis, but acidic hydrolysis were based on article published in 9 of July issue of Biomass and Bioenergy, published by Professor Lenz and Braga from Galway Ireland University, which is entitled Natural Fermentation as an Inoculation Strategy for Dark Fermentation of Ulbas species hydrolysis. Both chose algas as big plant which takes some same carbon dioxide. And in case of both island and coast Earth, India, it's sometimes increasing curves, increasing and needed to be collected due to macroalgas because due to the more over-accumulation hazard makes can cause freshwater and local freshwater and seawater unavailable due to cutting the light. Is potentially invasive also in India, not in, for example, in Vietnam, but India is invasive. Therefore, can be invasive, especially if close to the river, which are too salt, and that's why. And therefore, we need to reduce. So both researchers, Professor Rajesh and Rajesh Banu and Professor Lenz, proposed to check as biohydrogen fossils and utilize in this way, but first it needs to be optimally prepared to remove, to take cellulose, hemicellulose, and from lignin takes parts as the source of polymers as well as polyoxygenate and different compounds. But for make this, in this case, we focus on hydrogen production. We need to remove lignin part and solubilize cellulose and hydrosoluble salt. Therefore, Professor Rajesh Banu proposed two ultrasonic methods of integration. First, by alga cell walls by only ultrasonic ultrasonic disintegration in 500 milliliters macro 2 grams of algas with frequency 550 Hz, while the while in other, they propose ultrasulfurification with alkyl polyxoside, which is a non-anionic biosource biodegradable cells coming from algas also. So we have, after hydrolysis, we have disintegration, we have some surfactant. So we add this as help more and check how it works in comparison. Professor Lenz proposed for use, inoculum was taken from seaweed already living, and as hydrolyzed proposed a diluted acid thermal pretreatment of 35% and 100 Celsius. He chose for fermentation 300 milliliters. Professor Lenz, while Professor Rajesh Banu chose 200 milliliters, so quite similar batch fermentation both. Therefore, we should start. Was made, and the inoculum was sketched in for 30 meters in 100 Celsius. It was shocked and catch in 5 to 6 pH. Was replicated to check the hydrogen potential, and catch the temperature was 35 to 37. So mesophilic temperature was catch in case of Rajesh Banu. In case of Professor Lenz, we get two experiments, thermophilic and mesophilic. So in case he wanted to check two kinds, and both slightly large in case of Lenz was in case of thermophilic, which is bigger. So hydrogen was in case of preheat in case of thermophilic was 297, 5 it calculates. In case of Lenz without only mesophilic, the hydrogen was first phase was only 112. So this is the change, that mesophilic was 3 times higher, lower hydrogen production than thermophilic. But in case of ultrasound, so with dosage, they both cases give higher hydrogen in case of higher hydrogen was in case of adding surfactant method, but in case of ultrasonic and surfactant, where both release of conversion was 24% higher, and hydrogen was 130 milliliters, which is almost 50% higher than only ultrasonic. Therefore, we without only control was 6 times, which is in case of algas here, given 130 is higher than using in the mesophilic bath. For mesophilic conditions, the ultrasound conversion proposed by Banesh was higher than case of only acidic diluted. But still, there was bad for lower form for thermophilic. Thermophilic is 2 times higher. But in most cases, however, now when temperature is going so hot, for example, in Baghdad was 50 degrees, and this temperature would be for thermophilic fermentation very useful. The mesophilic are more because is, for example, in traditional 30 degrees medium Celsius temperature would be optimal because we don't need to add additional heating source to catch bacteria. But in case of thermophilia, we need to add something, and the question is if it's enough to replace. But in most cases, for example, in Europe, the mesophilic is mostly because there usually much more cost, much more thermophilic costly than mesophilic. Therefore, in case of the research of European research, the Banesh proposal is much better, and ultrasound is also cheaper because it's not corrosive as diluted as acid, so less strength material will needed, so it will be cheaper. So these are 2 solutions. And also Professor Banu checked if polyalkoxynate is better, and she checked that ultrasonic helps to make agas rest suitable more for polymer production. So we have this rest, the quite high production, and the better preparation for polymers production release by carbohydrate polymer is better in case of sulfate addition and ultrasonic. So these are 3 compositions that Professor Rajesh Banu proposed method. Investigation checked how it's feasible for polymer and energy. So 2 possible potential technical and economical suitability of process. So this is the fine. Thank you very much for listening me today and voice.